Today, we're going to talk about section 6.7, the fundamental theorem of algebra. I know you guys have all been waiting for that for a while. So, the fundamental theorem of algebra says that if you have a polynomial of degree n, remember, n would be the highest exponent, so like degree 4. And as long as n is greater than 0, then the equation, when you set it equal to 0, has at least one complex root. So we've found rational roots the last couple days. Now I'm here to tell you that we can also have complex roots. So what I'm saying is, would you gentlemen like to let the rest of us in on your joke? Okay. So the equation x cubed plus 3x squared plus 16x plus 48 equals 0 has 3 solutions. One at -3, one at 4i, and one at -4i. So remember, i's are coming back. You remember those from chapter 5. Also, the function x to the 4th plus 6x cubed plus 12x squared plus 8x has 4 zeros. One at -2, one at -2, one at -2, and one at 0. Yes. Okay. So that brings up what is a repeated solution. This is a solution that occurs more than once. Yes. So the -2's are repeated solutions. And just kind of a refresher here, if I have solutions at -2, what I would have to multiply is x plus 2 times x plus 2 times x plus 2 and x minus 0. So remember, since it's negatives, I have to have x minus a -2, so that's why it turns to a plus. So first thing we're going to do today is we're going to find all of the zeros of x to the 5th minus 2x to the 4th plus 8x squared minus 13x plus 6. So what do I need to find factors of?
6 and x.
Factors of 6. What numbers multiply to 6?
1, 2, 3.
Okay, and factors of 1. Just 1. So what are my possibilities? Plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 3 over 1, plus or minus 6 over 1. So, and you can reduce those fractions if you want. So if you want to go 1 plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, you are more than welcome to do that. Okay? Where do you guys want to start? You want to start at -2?
No, let's start at 1.
Okay. So Mackenzie wants to start at -2. Okay. Do I have all my powers of x's?
No.
What am I missing?
3.
So I've got to go 1, negative 2, put a 0 where x cubed would go, 8, negative 13, 6. Go through our synthetic division, drop the 1, negative 2, negative 4, 8, 8, negative 16, negative 8, 16, 3, negative 6, 0. Good guess. Okay, so that means we've got the function x plus 2 times x to the 4th minus 4x cubed plus 8x squared minus 8x plus 3. Whew, that looks ugly, huh? So, what do we want to do from here?
Do it again.
Do it again. Do you want to try another number? Should we try 1? Okay. So I'm going to go 1 up in the corner. So I'm going to go 1, negative 4, 8, negative 8, 3. So drop the 1, 1, negative 3, negative 3, 5, 5, negative 3, negative 3, 0. Hey, that works. Yes. So we've got x plus 2 times x minus 1 times x cubed minus 3x squared plus 5x minus 3. Got to do it again. So, can we factor this? Nope. So we got to do it again. Do it again. What number should we try?
I think, yeah. Thirdly, based on what the
Negative 1.
So, where do I always start if I don't know where to go? Always start with 1 and negative 1. 1, negative 3, 5, negative 3. So, but what if 1's a repeated solution? 1, 1, negative 2, negative 2, 3, 3, 0. Yeah, I was getting ahead of myself. Okay, so I've got the function x plus 2 times x minus 1 times x minus 1 times x squared minus 2x plus 3. Okay, so I have a repeated solution at 1. So if I factor this, can I factor this? X minus 1, x minus 2, does 1 and 2 multiply to 3?
No.
So, good try. So, since I can't factor this, what do I have to use?
That was a little too.
You go outside the inside, inside the outside.
So, you need numbers that multiply to 3 and add to negative 2. And in this case,
Well, then it could be 3, 1.
3 and 1, what are my signs?
Negative 3, 5,
So, what do my signs have to be, though? They both have to be negative.
Duh.
So, it's not going to work. So,
Oh.
use your quadratic formula.
I would love to listen to
Okay? What is my A value?
1.
What is B? And C? So that means it's going to leave me with a positive 2 plus or minus, guys, square root of negative 2 squared minus 4 times 1 times 3. All over 2 times 1. Two plus or minus the square root of 4 minus 12 all over 2, which gives me 2 plus or minus the square root of negative 8 divided by 2. And how can I simplify the square root of negative 8? Okay, I'll let you catch up then. What's that? Did you say, Julia? Yep, so I want to see, are there any perfect squares in 8? 4 and 2. So that means I can simplify this to 2 plus or minus the square root of 4. And because it's negative, I've got to put an I in there. Square root of 4, square root of 2, all over 2, which simplifies to 2 plus or minus square root of 4 is 2. I stays there. Square root of 2, all over 2. Now, what do you notice about 2, 2, this 2 in front of the I, and that 2? They're all divisible by 2. So, there's got to be this triangle here if you've got that addition sign in between. You cannot just cancel, say this second 2, instead of 2i, I had 3i. I couldn't just cancel the 2 2's. Okay? So that means I'm going to divide everything by 2. I'm going to get 1 plus or minus I times the square root of 2. Yes?
So what if we would have started off different than if it's negative 2? And if I started with a 1.
Would have ended up in the same place. So your numbers throughout the process would have changed, but you still would have gone through the same process. And then you would have still ended up down here where you end up with something that you can't factor. So then you'd still plug in your quadratic formula. So, good question.
Be faster than this way?
No, it'd be the same thing. Yep. Yeah. Because you're just going to get to different numbers, different process. So, your answer is going to be x plus 2, x minus 1, times x minus 1, times x minus the quantity of 1 plus I times the square root of 2, and x minus the quantity of 1 minus I times the square root of 2. Yes, it was.
It wasn't new, don't believe him.
Okay, questions on that?
So what's so different than what we did?
So it's not a lot different than what we did yesterday. Now we're just bringing in the complex numbers to it.
You set them equal to 0?
Yep, you still set them equal to 0.
You have to?
So no, this is where I want you to stop.
Okay. Yeah.
Okay. Good. Any other questions on this one? All right then. I want to talk about complex conjugates. We've talked about these before. We talked about these in chapter 5. So it is a little ways back. Complex conjugates means if you have an expression, you're going to have the same numbers. It's going to be a complex expression. You're going to have the same numbers. Different sign. In the middle. Different sign in the middle. So what I mean by that is, if I have what we just had, 1 plus I times the square root of 2, the complex conjugate of that is going to be 1 minus I times the square root of 2. So, these right here are complex conjugates. So, it's got to be in the complex plane. Complex number system. So, and I'm going to show you real quick why we like complex conjugates, if you guys remember. So, if I have, what did I do? 1 plus 3i times 1 minus 3i. And these have a certain pattern, and I'll let you guys figure these out. Figure out what it is. What?
Yeah, get that 3i out of there.
So, yep, when I multiply them together, I'm going to end up with all of my i's gone. So, if I multiply these, I'm going to use my FOIL. 1 times 1 is 1 outside minus 3i. 3i times 1 is going to be a positive 3i. And 3i times a negative 3i is going to give me negative 9i squared. If I have negative 3i plus 3i, what happens? Cancel out. And anybody remember anything special about I squared?
Negative 1.
Negative 1. I squared is negative 1. I mean, I squared is negative 1. Since I is a square root of negative 1, if I square that, I'm going to end up with negative 1. So you get 1 plus 9, which gives you 10. So part of it. Okay, so you're going to have to use these. So I'll show you what we're going to do with them today. Oh, sorry. Nope, I'll go back for you.
Hey.
All right. So what we're going to use to do these, we're going to write a polynomial function f of least degree that has real coefficients. So there's a keyword right there, real coefficients, no complex numbers allowed. A leading coefficient of 1, that's nice. I like that. Makes it a little easier. And 2 and 1 plus I as zeros. So how would I write it as in my parentheses if I have a solution of 2? So if I were going to factor it, you went through You found 2 as one of your numbers up in the box. How would I write that?
X minus.
Okay? We're going to do the same thing with our 1 plus I, that complex solution. 1 plus I, x minus the entire thing of 1 plus I. In order to get rid of the complex part of this, I'm going to use my complex conjugate in this. So I'm also going to have x minus 1 minus I. So 1 plus I, 1 minus I, those are complex conjugates. So this is just saying that we have these two numbers as zeros, but there could be more. Okay? Now, to make this a little easier, I'm going to distribute this negative throughout everything. Okay? So my expression is going to become still x minus 2 times x minus 1 minus I. And x minus 1 plus I. And now, I'm going to bracket in these last two sets of parentheses, I'm going to bracket what's the same. What is the same? X minus 1. So I'm going to treat that as one piece. I'm going to treat this as one piece. So now, when I multiply these in fact become complex conjugates. Correct. But we want complex conjugates because they're going to follow a pattern. Okay? The complex conjugate pattern is you're going to take your first part, in this case, our x minus 1. You're going to square it. You're going to put a subtraction sign, and you are going to square the second part. So, in this case, it's I. There's your pattern.
You always put a subtraction.
Always. So, we need to square x minus 1. But don't. Yes. So, when I distributed this, I got an x minus 1 minus I, and I got an x minus 1 plus I. So then I just bracketed those and took that as my real part, not the imaginary or the complex part. Is that going to make sense? Okay.
Do we have to put that or do we put
So
squared minus 1?
So since x squared minus 1 squared would not be correct, I would actually go through your FOIL process. Okay. If I FOIL this, x times x gives me x squared. X times negative 1 gives me negative x. Negative 1 times x gives me negative x. Negative 1 times negative 1 gives me a positive 1. So, No, they're not gonna cancel, but that's okay. Yes. So I'm going to get x squared minus 2x plus 1 minus, what is I squared, DeCam? What? I asked you a question. Would you please answer it? Oh, maybe one of these guys over here could help you. So, I squared is what, Nyron? -1. So, since I'm subtracting a negative, I add a positive. We're almost done, guys. So, I end up with x squared minus 2x plus 2 times x minus 2. Do you guys know how to multiply those two together?
Yep, use the box.
We're going to use the box. So, I'm going to put x squared minus 2x plus 2 x minus 2 here and here. X squared times x is going to give me what, Landon? Just x cubed. Yep. Negative 2x times x. Negative 2x squared. X times 2. Negative 2 times x squared. Negative 2 times negative 2x. Positive 4x. Negative 2 times negative 2. Minus 4. So we end up with x cubed. I have negative 2x squared to get a negative 4x squared. 4x plus 2x is going to give me 6x minus 4. And there is your final answer.